ways. Either on the console, I can write the command cd and the path name, and then using pwd command I can see. Second way, we can go to the file and we can change the current directory and display the current directory. There you can see under this file we have here change directory and current directory, so that you will not face any problem when you are dealing with the different images or videos. So now first I will show you the program for edge detection. So what we are doing in this program, we are reading one image. This is to clear the previous console. These are optional. So what you need to do now, you need to read the image. So let's say I am reading one image here. Let me show you this image. And after this demonstration, all of you can do the practice. So I'm reading the image, and this is the image. I am sure. Dear. So I hope you can see this image. Just give me once feedback on the chat box. Are you able to see this deer? Now on this image, we are going to find the different type of edge methods like Sobel, Canny, Privet, Log, etc. So are you able to see this image? Please reply on the chat box. Am I audible? Can you hear me?
Yes, sir.
Okay, can you see this deer?
Yes, 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 sir.
Okay. So now we have to find the edge. So as I told you, we need to convert this image. If we see the size of this image, this is of 3 channel. That is mathematically this is array. So we need to convert into matrix. So how to convert this into matrix? We have the method RGB to gray. So here I am writing here dir1 is equal to RGB to gray and passing the original image. And we can verify by using the function size. So here you can see now it is not showing the third channel which was earlier in the RGB image. And also we can use the imshow function dir1. So now here you can see now it has been converted from colored image to grayscale, or mathematically we have converted the image from array to matrix. Now to find the edge, it is very easy. Inbuilt function is there edge. So let's say edge, I am writing here pre-width is equal to edge and passing the variable dir1 and which method we want to implement. So let's say we want to implement pre-width method, and then we can say I am show edge pre-width. So in this way we are able to find the edge. Then we want to find the Sobel. So we can just replace the algorithm name by the Sobel. Sobel. And then we can say I am show this variable name. I am show edge Sobel. So now we can see the output. So now this is the output of the algorithm of Sobel. So this is giving comparatively better result. So similarly, we can see about the Kenny method. So what we need to pass here, the Kenny method. And this is a variable in which we are capturing these edges. And if we want to print these value, we can print here in this form, true and Boolean form, true and false. So I am sure we can pass here edge Kenny. So Kenny has given the better result as compared to the other two algorithms. Now how to find the help? You can write the help edge of any of the function. You can write help and the function name. So once you write, you can see the methodology here. So how we can find the edge? We have to pass this is the image, input image, and this is the method. So method could be Sobel. If we don't specify any method, by default Sobel is a default algorithm or method is there. We can pass similarly Kenny, Privet, and other methods. Along with that, we have optional threshold value which range from 0 to 1, and the default is 20%, that is 0.2. You can give the other algorithm also. Along with this, you can also give the direction. You can give you want to find the edges in horizontal direction or in vertical direction or in both directions. So that option also you can specify. And this will determine the direction to compute the image gradient. And even using the sigma method, you can control the amount of the attenuation of high frequency in some of the method. So you cannot use this sigma with the Kenny or threshold, only some of the method like FFT derivation. So now for the same method that I have shown you now, I'm going to change the threshold value. So using the arrow keys, you can, let me clear the console for your better clarity. Using the arrow keys, you can go back what all the commands you have run. So let's say here I am passing 0.5 this time, and we are saying I am show edge private. So now when we have given the 50% threshold value, we got this kind of output. Now I'm going to give the 0.1. Then you can see This is the output. So it depends on your threshold value, and default value is 0.2. So you will see the whatever it was there in the previous case. If you give 90%, so the value below 90% will be 0 and remaining will be 1. So you will find only very light here, very light. So it depends on your threshold value also. So now I'm coming back to the default one, 0.1, and we can see the output. Similarly, we can do with the Kenny method. So now all of you please try these three to four algorithms of edge detection. You can take any image. Now do the practice right now. So now with the Kenny, if I'm giving here 0.5 threshold value, and after that if I'm saying I am sure, so you can see the threshold value. So now I'm going to change this 0.5 to 50% to 10%. So you will find lot of edges will appear. So minute to minute, wherever there is a you can see. So here you can see this is a deer and remaining is a background. So these edges will help you in for your segmentation and many other image processing operations or as a part of the pre-processing. So now all of you please try these methods with the threshold and without threshold. So here edge detection. So here I'm writing the code for Kenny. So these are the optional. You can try with this or you can give any value. In case if you give like say other than these two value, so it's not going to make any changes. It will take maximum value is up to 1. If you see the output, you will find whether you do 100% or above 2, it will take the max, it will give the same output, and it will go beyond that. So you can you can try threshold values or also without threshold. Similarly, you can try with private method. And you can try with Sobel method. Now please try it right now, then we'll proceed further and gives different name. So please try to implement right now. And if there is any question, doubt, query regarding this finding the edge, you can write on the chat box. So you can ask right now if there is any question, query, doubt. And in case if you want to show multiple edge detection algorithms, so you can put sleep. So sleep 1000 means sleep for 1 second. It's about 1 millisecond, 1000 millisecond, and then show the other figure. Now next you can try with, okay, let me show you this program where you can see the deer. This is by first we have implemented the Sobel method, then Kenny method, then again Sobel with different threshold value. So I'm running it again. So on the same window, what we have done, we have given the delay using the sleep method. This is the inbuilt method, sleep. So what we are doing in this program, we are reading the image, converting into the grayscale, showing that image. So let's say I am show original image, then we will give one delay for 5 seconds. I am read RGB to read, then it will show the original, then it will show the grayscale, then it will find the Sobel image, show that image, then it will show the Kenny, and then finally Sobel. And similarly, if you want private, you can replace this method with the private. So once we run this, now you can see the original image. Then this image is going to convert into grayscale. So now we'll find the edges. Then again, edges using Kenny method. So this is the Kenny method, and this is the Sobel method. So please try to find. Now next we will see about how to introduce noise. So we'll read one image and we can introduce the noise and show the image with the noise. In case, now this is also very important parameter. When you are reading face, we have the very high dimensions. So sometimes you may get segmentation problems or problems. So you must use the stack size. Now what is this stack size? If you run this command stack size, it will tell you this value, 100,000, thousand time by this much. This is the size. So now what we are going to do, we are going to make it the maximum size. And after that, when you see the stack size, so from the default value, it will vary from system to system. Now we have given the maximum stack size, so that will not face any problem with the segmentation fault, buffering problem, or any other computation. Because when we are doing face recognition or some high-end image processing, so many pixels, we have a large amount of matrix or arrays there. Now to do the computation on that large dimensions, sometime you may get the problem of the stack. So you can increase the size using the stack size. So you must use the stack size. Now I'm going to read one image. So this is the image. Now this is the image. On this image, we want to introduce some noise. So again, there are salt and pepper, Gaussian, speckle, different uh, noise models are there. So now we'll introduce noise in this, and we'll see the output. So you can see very minutely small dots are there here. Small dots are there. Now we want to introduce different models. So again, you can take the help of help function and you can introduce I am noise. So again, under noise, we have salt and pepper, speckle, Gaussian, look, Poisson, and many more are there. So we can even use these examples. So after edge detection, second practical, all of you please try to perform on the noise. Noise models. Noise models. So here you read the some image, then introduce the noise. So I will show you one by one. So I'm going to read this image. Already I have downloaded in my folder. You can even see here. Okay, okay. Instead of Lina, now we can try on one image, one dot JPEG. So this is the image, original image, and this is a group of our students. And on this image, we will, after implementing the noise model, we will try to find the face, how many detection of face in the image. So first, let me introduce the noise. So we'll read the image. Image is one dot JPEG. Then I am show the image. So this is the image on which we are going to implement different noise models. So first, let's say Gaussian noise. So here, when I will zoom it, you can see now these small pixels. So this is a Gaussian noise. You can see Gaussian noise has been added to this image. So when we have to implement denoising, we have two options. Either we are noise models are known to us or unknown to us. If it's known, we can do the differentiation or subtraction of that model using median filter or different kind of filters. If the noise is not known to us, then we have to uh, make the hybrid approach, or based on certain random assumptions, we have to implement or propose our new algorithm. So next, now we'll see about the salt and pepper without any threshold values. So now you can see here So salt and pepper, kind of, you can see these pixel values. You can see these pixels. So this is salt and pepper noise. Now next we will implement with the threshold value. Same code I will copy paste in the chat box. You try to implement on your image. So let me first show you. So now on this image we have implemented salt and noise, but now this time you can see the in better clarity. So salt noise is in the form of white pixels or white, and pepper is in the form of black. So this is known as salt and pepper noise. Next, we can create our own noise. What we are doing, we are creating ones. Ones is the inbuilt function, zeros, these are the inbuilt function to generate the ones. So let me show you. If I say here ones 3 by 3, so it will generate a matrix of 3 by 3. Similarly, we have zeros, so 3 by 3, or any dimensions you can give. Even we have the function I, what it will do, it will generate the diagonal element will be 1 and remaining elements will be 0. Identity matrix. So in this way, there are a number of inbuilt functions are available. So now on that, we are finding the trill. Trill function will find the lower. So let me show you again. Trill once, let's say 5 by 5. So it will get the lower triangular in this form. And if we say once 5 by 5, so this was the original ones 5 by 1. So we get the lower triangular elements. So in this, we are generating the similar, and we are defining, and we are introducing this with the given image, and you can see here. So on the, we want to introduce noise, but only at the lower triangular of the image. So similarly, if you want upper, you can use the up trim function. So in this way, if you want to hide something, or so we can do in this way. So next, we can generate our own function, and we can see the noise now. So you can see now different type of noise is there. So all these models can be easily implemented. And finally, we can see about the speckle. So when we implemented this speckle, so you can see very small, very light kind of noise is there, very little speckle in nature. So now I'm copying paste this code in your chat box. Please try to implement these both method, edge detection and noise model. Next, we will work with the face detection, and then finally for the eyes detection. So I'm pasting the code in the chat box. So please try these examples. I will wait for another 2 to 3 minutes. Just you run these code and replace the variable name with your own image. So on the chat box, now code has been shared. And you can feel free to ask any question if there is any doubt, question, query. After this, we'll do the experiment on face detection, then on eyes detection, and then on the video processing. So remaining code you can access from the two books that I've shown you from the scilab.in. You can download those two books. Each and every chapter code is given there. So now you can feel free for any doubt, question, query.
Sir, is it possible to check it with the real-time images? Because
Yes, we can work with the real-time images also. These are the real-time images. You can take your own image also.
many times we find that in MATLAB also we have some standard images. So like this, is there any standard images are used for Scilab, or what will be the general standard uh, the images that is used in MATLAB? Can we use it here, sir?
One second, because right now I'm using desktop speaker, so it's very low. It's bit. I am using directly the microphone. So I am able to hear you, but this audio is too low as it was there in my case earlier. So I request Madam Aman, if she can rephrase the question, can you answer the question, or you can write on the chat box.
Sir, madam,
Sir, your no voice is not
sir,
audible. I can't hear you.
madam, madam, can you hear me now?
My audio
Uh,
or participants
yes,
audio,
sir.
madam?
Rangarjan, sir, I
Sir,
can hear you.
madam, I want to ask that whether there is any standard images available for using for working with Scilab, or can we use the images that is used in MATLAB here?
Okay, I understood your question. You are asking about the benchmark images or any. You
Yes,
can
yes, sir.
work with any image, no issue.
Yes, sir. Yes,
And
sir.
even in the
That's what I am
Scilab, there
asking.
are certain images are there. So let me show you. When you install the Scilab, I hope you can see my desktop.
Yes, sir. Yes, sir.
So I'm going to go to the PC and under C, yes, in C, because when you download and install the Scilab, the size is only in MBs, whereas in MATLAB it's in around
Yes,
30
sir.
GB to 40 GB. So they have
Oh,
huge effort of the images, but also in Scilab, when you download these images, when you install the toolbox, so these toolboxes are under, let me see here. C users under app data local. I will copy paste also this path. Then whatever you are downloading softwares, like in my case Scilab, or if you write the simple Scilab, let me see the there is a folder. Let me show you. There is a command here. Using that, you can find help. There is an inbuilt function that I'm going to use. Next program, detect faces. So they are taking the some of the sample images. Not detect images, detect faces. Program name is detect faces. Help detect faces. So here they have given the one variable, global variable name SIVB path. So there is a this is a function get SIVP path, because this is a toolbox that we have installed. Now we want to see where it has been installed. So we can run this function. So similarly, in your case, these images data sets, images samples, we can say, are stored under this C user. Now this is will be your username app data under roaming. There is a Scilab version, atoms, whatever toolboxes you are going to install. So let me show you this. Similarly, if you have installed Scilab, you can open, you can follow me. C users, go to your username, then app data, and under app data there is a folder roaming. You can see here. You go to your C users username, app data, then you can click on the roaming. There is a folder roaming. When you click on the roaming, you have so many softwares are available, whatever softwares you have installed. So like here, you can see the Scilab. You can see the Scilab. So I'm repeating C users, your username, your whatever your login name is there. Then go to the app data. Then go to the folder roaming, and then go to the Scilab. So under this Scilab, these are the versions that I have installed. So I have installed Scilab 5.5.2. Then go to this folder atoms. 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 Now under these are the toolboxes that we have installed so far. So whatever the toolboxes you have installed, you will see those folders. So like IPT3, this is the version, you will get the other macro description, etc. So now here we have used this toolbox SIVP. So we'll open this SIVP version. Now under this you can see the images. So here you have the, for the next processing, it will help you for video processing. You have some Lina, people, peppers. So few sample is there available. So this is the path. So let me copy this path to your chat box, or the command is get SIVP. I hope now you got it.
Yes, sir. Yes, sir.
And
Thank you, sir.
I am also writing the command so that you can follow it anytime. Get SIVP path. You can try right now. So I request again all the participants, please try to run these two very easy. How to find the edge and how to get the noise level. Then next we are moving to face detection. So shall we go
Face
ahead?
distance போறாரு.
So shall we go ahead and uh,
10 நிமிஷம் எதுக்கு நிக்கணும் போய் நான் பண்ண அங்கே போய் நின்று கிறுக்கணும்
so even you can
எல்லாம்
copy,
ஃபைட்காரன் எடுப்பாங்க கிறுக்கணுங்க வந்து
you can copy, you can
ஏதோ 10
copy,
நிமிஷம் முன்னாடி விடுறாரு சந்தோஷமா விட்டு அங்கே போய் 10 நிமிஷம் முன்னாடி போறதுக்காக போய் தொங்கி தொங்கி நின்றுட்டு அப்புறம் இன்னும் கேவலம்
you can copy paste also. Now next we are going to go for the face detection. So in your case, you can try this. It will read the Lina image and detect the face. Before that, let me show you one real-time application, real-time image. So what we are doing here, we are reading one image. So let me show you that image. Let's say this is a image 1. I am show, I am 1. This is the one first image number 1, and we are to find the face, detect the face. Second, we will read another image. And we'll say I am show, I am 2. So this is another image where we have multiple faces. So now what is our aim? Our aim is that wherever there is a face, make a rectangle over that face. So our algorithm has to do two things. One, to detect the face, and secondly, draw the rectangle with a given color on the face. Now there may be possibility that it may detect this as a face, or this may be as a face. So these are known as false negative. So let's see, we will try the algorithm. So first I will try on image 1, then image 2. So we'll see now. So when we run this method, what we have done, we have read one image, and then directly we are passing this function on this image. Image is IM1. And what is the inbuilt function? Detect faces. So it will return something. Now what is that? Oh, now we are running this. It will return certain values, and so now we have to draw the rectangle. So we will find the size. So if we see the size of the face, it is 14 by 4. So 14 by 4 means 14 row and 4 columns. So these are the features. That means it has detected how many faces? 14 faces. It has detected how many faces? 14 faces. It has detected 14. So it is going to make 14 rectangles on those faces, 14. I'm closing this one. And then we will use the loop. So for I1 colon M, M means for 14 times, it is going to draw the rectangle on the face image, and this is our face, and these are the color. If you are aware of the HTML code, first for the red color, second for the green, and third for the blue. And even we can do this is a hexadecimal code, sort of hexadecimal like in HTML. This is a coding RGB. We can mix also 255 plus 255. So red and green will become a new color. Similarly, green plus blue will come some other color. So for the time being, what color we are going to make? Green. So we will write here. So directly I'm writing image, detect faces. So first we are reading the image, we are detecting the face, then we are capturing the size. So this is the size 14 by 4, 14 column, 14 rows and 4 column. So it for I1 to 14, that means it has detected how many faces? 14 faces. And then draw a rectangle on that faces. So now let me run this program. So you can see it has not detected all the faces. It has left the sum of the faces. So this algorithm has not given good performance on this image. So you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So now we'll try with the second image. So just we will replace with the second image, and we'll now run this program. So if we see the value of now M, so if I write here M is 38 and N is again 4. So that means it has detected how many faces? 38 faces. So you can see now, this time on this image it has given the better clarity, but it has left this one face, this another face, and this was the false. This was not the face, but it has detected like this. But in this case, and it has left 3-4 faces, but it has given the better result. So it depends on the data and the algorithm. Now next we'll do finally the face detection that all of you can try. And I am copy paste this code on the chat box. Just you copy paste. What it will do, let me explain here. Let me clear the console. So this is the inbuilt function. It will get the path where our this toolbox is there. Then with that toolbox, that path, and under there is a folder images and Lena. So it's going to read one single image, and then it's going to detect the face. So this time it will return, because there is only one face, so m value will be 1. So for I is equal to 1 to 1, draw the rectangle. So you can see now. This is output. Now we want to change this color to blue. So what we'll do, simple, this is R, this is for green, this is for blue. So 255 we'll do here. That's all. And now you can see we got the blue color. So all of you please try to run this program. Then we'll move to the eye detection program. From the chat box, I copied the code. All of you please try this code. And if there is any doubt, question, query. Yes, Dr. Kaushalya, any doubt, question, query? Or any other participant? Next, we'll go for then for the eye detection. So let me see what is the image here. So we are reading one image. I am sure I am. So now this is one image of a baby. We'll try on the Lena and as well as on this image. So first let me show you the output. So it's giving issue with the, so we'll read the Lena image. That is also in my current folder. And the file extension is, we'll see using the properties. Then click on the properties. So the extension is PNG. So on this image now we want to find the eyes. So let me open the code. So we are reading the Lina image, and on that we are going to find the eye detection. So it will work with all of you, because I am taking the benchmark or the image that comes with the Scilab. So now here you can see the output. Now how it has happened, because we have to write separate algorithm for left eye and separate algorithm or steps for the right eye. We need to find the coordinates from the face. First we need to detect the face. So how it is working? So let me see. Now this is a face. We have to find the coordinates. So from the top left corner we have to find the for the right eye. So this is if we move, this is the right side. This is the right eye, and this is the left eye, because this face is toward us, and we have to find the coordinate from this direction and find the coordinate, and on that area we have to find the features and find the right and left eye. So here on the chat box for eye, this is the code for eye detection, and after this we'll run the last code for video processing. So you can try to change the color. So earlier we were giving here red color, green color. So let's say we want to give mixture of red and blue, and here we want to give the uh, white color. So white color is a mixture of red, green and blue. So this is for the left eye. So you can see here. So in this way we can change the color also. So you can try with your images also. So what we have done in this, first we have read the image. That is the first step. After reading the image, we have run the face detection method. Then we have find the coordinates for the right area and for the right rectangle. Then we have crop, we have get the region of interest. Then we have detected the detect right eyes, and similarly we have done with the, after cropping the region of eye ROI, we got the detect the left eyes. Then we have to specify the size, and similarly what we have done for the face detection, similarly, because there may be multiple faces, multiple eyes, so on those we can try to run these coordinates and try to draw the rectangle. So in rectangular we have to give the coordinates and then the last option for the color, and similarly we have done for the left eye. So please now try these programs and you can reply on the chat box whether you are able to run successfully or is there any issue. So next we'll move to the video processing. So video, if we see the logically, it's nothing but the combination of multiple images or multiple frames. We must have that video. So you can see these are the 3-4 videos are there. Here we have these videos. So let's say we will run this red car video. Here we are giving red car video, or you can give the path that you have given to the face and eyes. So this is in my under folder images. Then we'll open this video. You can even do the reverse. So first we'll do, let's say we don't know how many frames are there. So for index from 0 to 40 frame, it is going to read 0 to 40 frames and show that image. And then we are going to close that video. So there is a then when you run this video processing, there might be probability of 1%. It may give the problem of the codec. So I will show you how to solve that problem. So let's see the output. So you can see here for 0 to 40 it has shown only the 40 frames. Now we'll increase the value. Let's say we don't know how many frames are there. So if it's 30 frame per second, it depends on that. And if it's 10-second video, so there will be 300 frames. And if it's a 1 minute, accordingly. So we are giving some random number. So you can see now here. Okay, we'll give some more. So it's not able to read further, but on the window, it's able to run these many frames. So that depend on the length of the frames. Now we want to see in reverse order. Let's say for 1000, let's say there is a 1000 to 0. So we are capturing that index and we are going to show that. Or let's say 400 to this is a very small video. If it could be of the large video, then you could have seen. So in this way we can read the video. So here I am passing the frames 0 to, let's say, 400, and it's going to show. So this is a very small video. So now this is the last program. So all of you now try to run this. So there may be probability, then if in case if it's not working, there may be problem with the codec. So for that you need to go to the xvid.org site and you need to download that video. So now we'll take here the question queries. Now we'll take the question queries here. So any question query related to face detection, eyes detection, noise introduction, edge detection, and videos. So please try to run the code, because these were some videos. The length of the code depend on how much second. Let's say if it's of 10 second. So normal standard frame rate is 25 or 30 frames per second. So for 10-second video, there will be 300 frames. You can try, you might have your own video, or on your machine you might have some certain videos. You can try that also. So if you try with any software, or then you will be able to find. And now I will put the VLC video player. So you can replace with this your own video, any MPEG or AVI video. Try to run and try to see frame by frame. And also you can introduce delay using the sleep function. So that's all for today, and here you can see, so it's only up to 8 seconds, that means around 240 frames. 202, it's only of 8-second frame video. You can see this here. So because of that reason, the total number of frames will be around 30 into 240 frames. So frame will be, instead of 400, you can replace now with the 240. and the file name was video. So now you can, with your own custom images and videos, you can try to run these. So now we know it's 8 seconds, so it's not giving any other issue or problem. So any other question? Okay, if there is no any other question queries, so I request all the participants to kindly run the code that I shared the presentation in the PPT, the basic image operations, then the two books that I've shown you about the image processing, and you can, after that you can try to run face detection, eyes detection, video processing, and uh, how to detect, how to introduce noise, etc. So with these words, we stop here.